Hello everyone. In this video I'm going to talk about angle properties of a circle. In talking about angle properties of a circle, let's take a look at this situation. We let O be the center of the circle and ABC are points lying on the circumference of the circle, just like this. And there is a relation between angles at the center and the angles at the circumference. And now I would first prove it to you first, and then I would write the result next to it. In a figure like this, we can join OC. Okay, extend from CO like here, and then we name this angle as A and this angle as B. And since OA, OB, and OC are radii of the circle, so by base angles isosceles triangle, we have this angle as A and this angle as B. Now, angle AO dot is the sum of these two angles. So this is 2A by the exterior angle of triangle. And now, angle BOI O dot is also the sum of these two angles, which is 2B. Now, can you see the angle at the circumference, which is the sum of A and B, and the angle at center is 2A and 2B? Yes, the angle here and the angle here are in special relation. So if I let it be X and this angle be Y, then we will have Y equals 2X. Now, when you use this result, you need to quote the reference. The reference is like this: angle at center twice angle at circumference. And you may wonder if it's still true in different kinds of situations. Now let's take a look at the following situations. I still have the center O here. We have the 2 points A and B, and there's a point C lying on the circumference. And since C is at a different position, we cannot draw the two isosceles triangle easily. And now we are going to investigate the relation between these two. I still name it as Y. This is X, and I would like to show the relation that Y is 2X. Now, in order to do this, we still join the line OC, and we still have OA, OB, OC being the radii of the circle. And now, in order to find the relation between X and Y, we can let this angle be, say, A. Now, we will have this angle being A as well. And angle O BOI C is A plus X. Now, what is this angle? You can find it in two ways. First, when you consider triangle O BOI C is actually 180 degrees minus 2 of A plus X. But then when you consider the triangle OAC, you can form this angle to be 180 degrees minus 2A and minus Y. Remove the bracket, you will have 180 degrees cancelled out, minus 2A cancelled out, and you will get negative 2X equals negative Y, and thus Y is indeed 2X. Okay, so no matter where the position of C is, we will have the angle at center being twice the angle at the circumference. Now, the third situation is like this. if I have the O here, AB here, and the point C is now here. Now, in order to locate the angle at center, twice angle at the circumference, we need to be very careful with what do we mean by the angle at center and what do we mean by the angle at the circumference. One way to distinguish is the direction of angle drawn. Okay, I like this kind of way to identify the two angles. Okay, the thing is like this. When you draw the angle at center and the circumference, the direction would be the same. What do we mean by direction? You can think of the arc, the small arc indicating the circle is something like this. This arc is pointing like in this direction, and the angle at the circumference would follow the same direction here. So as this one, when we consider the angle x here, it is pointing in this direction, and the angle y is pointing in the same direction. Now, for angle AC boy, angle at the circumference, we will indicate like this. Okay, this should be our x. And notice that the angle x here is pointing in this direction. And actually, the angle at center, you can consider two different angles. One is the angle AOB here, and another one is the reflex angle AOB. Notice that this angle AOB is pointing in this direction, and the reflex angle AOB is pointing in this direction. And now you should figure out that the angle at center, that is the y, is the reflex angle AOB. Okay? So this is the first property related to angles in a circle. Okay? Now the second one, since the point C here, okay, with the same position of A and B, the point C can actually be any points on the same side. Okay, in this situation, C lies on the major arc of AB. Okay, no matter what the position of C is, we still have the relation y equals 2x. That means the angle at center would be the twice angle at the circumference. Now, with the same angle at center, we should have the same angle at the circumference. Just like this. If we have 2 points, A and B, and if we have another 2 points which is lying on the same side of arc, like both points lie on the major arc of AB, or both points are lying on the minor arc of AB. Okay, I call it, say, C and D. Then these two angles drawn from the 2 points A and B would be the same, because they have the same angle at circumference. Like if I have this x, then I will have 2x here, and since here is 2x, we have an x here. Then we can just rub the dotted line out, we get these two angles being the same. And also, by the same argument, we should have these two angles being the same, say y. Okay, So if there are 2 points lying on the circumference of the circle, we have angle AC boy equals angle A dot boy. Okay, and of course, we should have angle CA dot equals angle C boy dot. Okay, etc. And you should have angle boy A dot equals to angle boy C dot as well, and so on. Okay, whenever you want to use this property, you need to quote the reference angles in the same segment. Okay. Number 3. Since we have the angle at center equals to the twice angle at the circumference, what about if we have the angle at center being a straight angle? Here, when the 2 points joining together A and B passes through center O, then AB is indeed the diameter of the circle. And that means the angle at center here is 180 degrees. That means the angle at the circumference would be half of it, and that is a right angle. So in order to use this specific angle, 90 degrees, then we can directly quote the reference. The angle in semicircle is 90 degrees, because A boy C is indeed a semicircle. Okay? Now number 4, because you know that the angle at center being twice the angle at the circumference is there is a special case here when you consider the 2 points joining together is a diameter, right? So if we don't know, okay, the position of A and B, but we know that the angle at the circumference is given to be 90 degrees. Then what do we have? We actually have angle at center twice angle at the circumference, right? And the angle at the circumference is a straight angle indeed. And thus AOB is a straight line. Okay, so we can have different kinds of result which basically mean the same thing. We can say that AOB are collinear. That means AOB is a straight line. We can also say that AB is a diameter of the circle. We can also say that ABC is a semicircle. Okay, it's about geometric relation between ABC or AB with the with the circle. So when you want to use this kind of result, then you need to quote the reference converse of angle in semicircle. Okay, so this video is a little bit long. We still have 2 more angle properties coming up. Okay, see you in the next video, and thanks for watching.